Nope, doesn't sound very educational. All right, here we go. Just so you know, this is my function right here. I'm kind of just making it a little bit darker. There we go. All right. So we evaluated functions, analytically by just simply plugging it in and see what we came up with. Now we want to actually look at the graph. Today we're going to get a visual representation for a lot of these things. So the graph, given the graph of the function f, identify the following: f of -2, f of -1, f of 0, f of 1, and f of 2. So that means if I have an x value of -2, what is the height of the function at that spot? 0. F of -1, if you plug in -1, what is your output? Is it 3, or is it 0.7, or is it undefined? It's 3. That's where you have a circle filled in, so we would say 3. F of 0, undefined. Why? Yeah, this is something that's headed up very close to a vertical line, and so it's not going to touch. It's going to head up towards infinity, but it's never going to cross over. And then you have this open circle there. So -1 is undefined. F of -1 is undefined. I'm sorry, f of 0 is undefined. F of 1, 2. Yes? At 1, it's filled in at 2. It's not filled in there. F of 2, as you said, it looks like about 3.4. All right, for the domain, I'm going to grab a vertical line, and I'm going to drag it across this graph. It now says state the domain in the range of f. Will the graph cross over here? Yes. Does it cross here? Here. 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 No, not at 0. Because you have this graph is headed up vertical right along the line. It's not going to touch it. It's not going to cross it. And you have an open circle there. Does it cross here? 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 Yeah. So everywhere except for 0. So -infinity to 0, and then union with 0 to infinity. So that way I've excluded the value 0. 0 is excluded from the domain. Now we do the range. I start down here. Will the graph eventually cross down here? Now you can see this line headed down like that. Is the graph going to cross here? Yep. How about here? Yeah, it crosses right there. It doesn't there, but it does cross here. Yep. Yep, looks like everything. Now, what are the domain values that satisfy f of x is equal to 2? Is 2 an x value or a y value? It's a y value. So I take my horizontal line and put it at a height of 2. How many times does the graph have an x value of 2? 6 times. Once, twice, 3 times, 4 times, 5 times, 6 times. So we want to state the x values that will give us an output of 2. Estimate them. What would this one be right here? Sure, -1.5. How about this one? -0.25. How about this one? Very good, 1/2. That one. $1.5. 3. 6 spots. So when I give that question on the test, you know, if you miss one, you know, let's say it's worth 2 points. You miss one, I only give you 1 point. That shouldn't be a real difficult question, but you got to pay careful attention. Just go in order. Okay. All right, flip it over. Copy down these graphs as best as you can. They don't have to be perfect. The directions state that you should use the vertical line test to determine if the following are functions. The vertical line test says what? If it is a function, it will only cross a vertical line in one spot. Okay? If a graph crosses a vertical line in more than one spot, it is then not a function. So therefore, we take this vertical line and drag it across. Is this a function? Yes. Yeah, I got erased. Is this a function? No. Is this a function? Am I okay here? 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 So what's the problem? Oh, right there. It's got a vertical line, and a vertical line is not a function. No. The graphs do not have to be connected graphs. They could be what we call discrete graphs. Crosses once, 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 once. Is that a function? Yes. You can also examine functions from an analytical standpoint, meaning we are going to look at the algebra. We're going to solve for y and determine whether or not we get one solution or two solutions. So it says determine whether the equation satisfies or defines y as a function of x. And so we are going to do some algebra here as opposed to looking at the graph. I'm going to solve for y. Negative 4y equals negative 2x squared plus 8. Divide by negative 4. Y is 1/2 x squared minus 2. Notice what happens when I go into y equals. Am I allowed to type in the equation as 2x squared minus 4y equals 8? No, you're not. In fact, your calculator expects that if you write y equals, then you can type it in and you will get a function. If you go into mode, notice that you are in function mode. You are not in parametric, polar, or sequential. If you want to graph something that's not a function, then you would grab one of these instead. Okay? So your calculator doesn't know how to graph something that's not a function. So when you place in this form, watch what happens. Give me a value for x. 4. 4 squared is 16 times 1/2 minus 2. Were you concerned that you would ever get more than one value out when you plug something in? So therefore, this is a function. It's defined as a function of y is a function of x. So yes, this is a function. We've solved and we've got 1y. Watch what happens here. What kind of graph is that? X squared plus y squared is 9. Covered it this year. Circle centered at 0, 0, radius of 3. Very good. So is a circle a function? How many times does a circle generally cross a vertical line? Generally, it will be twice, except on the endpoints will be tangent once. Okay. So what we're going to look at here is if we solve for y, we get y squared is equal to 9 minus x squared. When you square root both sides, when you square root a variable, How many solutions do you come up with? 2. So we have a positive y and a negative y, and we have the square root of 9 minus x squared. So now, if you plug in a value, suppose I plug in 0. What is 9 minus 0 squared? 9, square root of 9, 3, and it says you get a positive 3 and a negative 3. So when I plug in a value of 0, I have 2 different outputs. So you can see this says 2, this says 1. So this is not a function. Again, what you're looking at is right here. Okay. Look at the next one. I'm going to add a y to the third. X plus 3 is equal to y to the third. How do we get rid of a cubed? Cube root. So the cube root of x plus 3 is equal to, let's think about this. When you cube root a positive, what do you come up with? A positive. When you cube root 0, you come up with 0. When you cube root a negative, you come up with, you never come up with more than one result, do you? So therefore, in this situation, you can see that you have one result. One result. So yes, this is a function. Now, some people may say, well, if there's a cube on this, only if it's an odd or even power would it not be a function. Not necessarily. If we could alter this a little bit, and instead of a y to the third, if we put this in there, y minus y to the third plus y plus 3 is equal to 0, all of a sudden solving for y becomes much more difficult. And it's harder to tell whether or not that is a function. Okay, so you're not going to see examples like that, but you should be able to do the basic ones like we've seen. All right, our last piece of business for the day is example 4, and then you can have your assignment. We want to graph piecewise functions. If you can do this, you can do everything on the test. I think that for some people, this is the hardest content for the test. You have to be able to graph these over a certain domain. Now, you were able to evaluate these piecewise functions for a given domain, but now we want to graph them. And what you have to do first, you don't have to write this down. This is kind of the scratch work I do. But as soon as I look at these graphs, I recognize you have two functions, y equals 3 and y equals x minus 4. What shape does that make? What is that graph? What kind of line? All lines are straight. A linear line. Very good. What kind of a horizontal line? Thank you. I don't get it. All right. Okay. This is a horizontal line. What kind of line is this? Linear line. Very good. What is the slope? 1. Crosses through? -4. So you can see that this is the graph that I'm kind of looking for. But does this pass the vertical line test? No. And it says it's a function. So we don't want this whole graph. We just want parts of this graph. Let's look at the parts of this graph that we want. We want y equals 3 up until 2. For all x values are less than 2, we take y is equal to 3. Right now on this graph, am I less than 2? Am I now? 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 And I can't be equal to 2, so I use an open circle. Let's look at the next part. X minus 4 when you're greater than or equal to 2. Am I greater than or equal to 2 here? No. How about here? 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 Yes. Here? Yeah, so we'll continue on there. So the green part is actually the graph. Not the blue part, the green part. The blue part is what comes into my head as the image of what I need to graph. And then I cut it at the line x equals 2. That's where it gets cut. So here's how I actually teach people how to do the problem. I teach them to cut it first. We cut it for a value of 2. This is where it's cut. It's cut at 2. Look at this. If you take 2 and plug it into this function, what do you get? You get 3. If you take 2 and plug it into this function, what do you get? -2. So these are my endpoints of my graphs. 2, 3. Over 2, up 3. Open circle or closed circle? Open. 2, -2. Open circle or closed circle? Now, I want the graph of 3 off to that side, and x minus 4. What's the slope of that line? 1. So from this point, I could just go over 1 and up 1, over 1 and up 1, over 1, up 1. You tell me. This line that I've drawn here, some people don't like that because they say, hey, you didn't cross through -4. Why can't I cross through -4? Then it wouldn't be a function. It wouldn't pass the vertical line test there. I have to just draw values for x greater than 2. That's what I want. Now, if I would continue this on, does it look like it would cross through -4? Yeah. So let's try the next one. Again, if I were you, I wouldn't draw what I draw in blue, okay? So g of x is x plus 3, so we have two functions, y equals x plus 3, and we have y equals x squared. What does x plus 3 look like? Slope of through 3. What does x squared look like? Parabola centered at 0, 0. So that's the vision you want to have in your brain. Now it's a matter of taking that and slicing it at -1. So we're going to slice it right at -1. So here's how I slice it. I take -1 and I plug it into each so I can figure out the endpoints. -1 plus 3, 2. -1 squared, 1. -1, 2. So back 1, up 2. Open or close circle? Closed. -1, 1. Open or close circle? Open. Let's look at that first graph. X plus 3. I want to draw a graph with a slope of +1. Do I want to move forward from this spot or back from this spot? I need to move to the left or right? The left, correct? So I'm going to go down 1, back 1. Down 1, back 1. So some people don't like this because they're like, well, you drew the line going down. That has a negative slope. We measure slope moving from left to right. The line goes up, moving left to right. So this has a positive slope. And then this graph, we know, just continues as a parabola. You told me it goes down to 0 and it comes back up. So there's that graph. Does that pass the vertical line test? Yes, so it's a function. If you draw these graphs on your test, many times people do these graphs on the test and their graphs cross each other. And they're not functions. It's like, well, it has to pass the vertical line test because it tells you right away, this is a function. And this one has 3 parts to it, 3 pieces. We have y equals 4 minus x squared. We have y equals -2. We have y equals x minus 5. So when I think about these graphs, I try to picture this in my brain right away. What does 4 minus x squared look like? A parabola, shifted up 4 units. And is it right side up or upside down? Yeah. So that's my parabola. What does -2 look like? Horizontal line through -2. X minus 5. So those are the 3 graphs, but I'm just going to have sections of those graphs. I now need to determine what sections do I have. So I will slice the graph at the points that it tells me. The first one, when you plug in 1, what do you get? 3. Second one, you plug in -2, what do you get? I'm sorry, you plug in 1, what do you get? -2. It's always equal to -2. You plug in, I've got two parts here I need to check. You plug in 3, what do you get? You always get -2. The bottom one, you plug in 3, you get -2. Do I have any closed circles on this graph? No, they're all open. They're all open. Question. Because it's cut in 2 spots. So 4 minus x squared, I've got my endpoint at over 1 and up 3. We said they're all open circles. What does it do from there? Does it go down? Does it go up? It goes up. It goes up to what value? It goes up to 4. We drew the graph earlier. We know it does that. One -2 and 3 -2. We know that those are both open circles. And it's a horizontal line. And then the last one, 3 -2, we've already plotted that open circle. What's the slope of that line? So we just head up with a slope of 1. Does that pass the vertical line test? So it is a function. So at least I have an idea that maybe I've done it correctly. How's that? Your assignment. Right there. What? So, Foster brings up an excellent point. We'll see if anybody else has this question. Is 1 part of the domain of this function? No. Is 3 part of the domain? Is it okay for a function to not have all values in its domain? Just like this example right here. This only has 4 elements of its domain. Yet is it a function? Yes. You don't have, your piecewise functions don't have to be connected, nor do they have to include all real numbers. You must look at the symbols to determine. It can skip values. We could have, say stop 3 here and pick up at 4 there. Okay. So again, your assignment. Excellent question. Here's your assignment. A little bit lengthier than yesterday's, but I told you guys I gave you kind of a break yesterday. Thank you, Mr. Gantz. You're a very nice person, Mr. Gantz. Hi there. Welcome to my classroom. Let me see if everybody's here. He's here. He's here. He's here. Oh, gosh. Thank you very much. Let me turn this before I get fired here.